So let's take a look at our next section 2.5. Our goal today is I can solve a quadratic equation by factoring. So remember I told you before that we need to be able to factor in order to do something else. So what we're going to do is we're going to use factoring to solve a quadratic equation. So first of all, like in a linear equation, when we solve a quadratic equation, we're finding values of x that make the equation hold true. What makes a quadratic equation different than a linear equation is that often we have both an x and an x squared in the question. Okay, and this making it impossible just to isolate the x by just rearranging. Okay, so we have a little bit of an issue here. So now if we can factor, in other words, write the equation as a product, then it becomes much easier to discover what values of the variable will work. All right, so we'll start with a very simple equation, and the simple equation is a times b equals 0. Okay, it could be 3 times 4, it could be x minus 2 times x plus 4, but a times a b equals 0. Now mathematically, what do we know about a and b? Well, we actually know stuff about them already, even though we don't know what numbers they stand for. Okay, one of them must be 0. Okay, the only way that two things can multiply to 0 is if one of the factors is 0, right? So what do we know about the brackets in the following equations? So for instance, if I have x plus 3 times a 3x minus 9 equals 0. Well, if I use the same process that we talked about here, okay, that same process, it's the exact same thing, it means that we know that one of them has to equal 0, because the only way two things can multiply to 0 is if one of those factors is 0. So it applies here the same way as if I knew what a and b were as far as numbers go. Okay, so we're going to use this process, what this knowledge of a number times a number equals 0, that at least one of the numbers has to equal 0 in order to solve quadratics. So let's take a look at this here. That would mean that if we take that equation, I just cloned it, it means a couple different things. It either means this is equal to 0, so in other words, x plus 3 equals 0, or, or actually, it means this has to equal 0, so that would mean 2x minus 9 equals 0. Now, both of these are simple equations that you can solve. Okay, so you know you could subtract 3 from both sides and you would end up with x equals negative 3. On the next side, we could add 9 to both sides. We would end up with 2x equals positive 9. And then we could divide both sides by 2 and end up with x equals 9 over 2. So in fact, we factored this quadratic. Someone factored it for us, but it's factored, and that way we're able to solve for x. So what we're looking at here is the answers to a quadratic equation are called the roots of the equation. Okay, we'll be talking more about those roots. Okay, so first example, solve an equation that's already in factored form. So again, someone has factored it for us. Okay, and so we have our two factors. So we already know then that either this bracket equals 0 or this bracket equals 0. Okay, so we're going to set both brackets equal to 0 and solve for x. So the first one, x minus 2 equals 0, so we would add 2 to both sides, and we end up that x equals 2. On this side, we would have 4x plus 1 equals 0, and then to solve for x, we would subtract 1 from both sides. and that would give us a 4x minus 1, and we would divide both sides by 4 to get x equals negative a quarter. So if I'm asked to solve this, my solution, I would show both of these, and that would mean x equals 2 and x equals negative a quarter. So there's two answers for x in this case. Now the next types of questions are factor to solve. Now one thing that you should know, in order to solve, you have to have one side equal to 0 in order for it to work. Because remember, we use this property, a times b equals 0. So that means that it has to equal 0 on the one side. So let's take a look at the first question. The first question is n squared plus 9n plus 18 equals 0. Okay, so now we have to factor that. So I need two numbers that multiply to give me 18. They add to give me 9. Both brackets are positive. Okay, so I'm thinking 18. So 9 times 9 and 2, but when I add them I get 11. So 3 and 6 would work. So n equals 6 and n equals 3. So I know that has to equal 0. So when I set each of these brackets equal to 0, this will produce n equals negative 6, and this one will produce n equals negative 3. So my answer is n is negative 6 and negative 3. Now when I look at the next question, part B, my problem is here I don't have this equal to 0. So the first thing I'm going to do is I'm going to get everything to the one side. So that means I need to get the 33k to the other side. The way to do that is I'm going to subtract negative 33k from both sides. And so then what I'm left with is I'm left with the equation of 3k squared minus 33k plus 72 equals 0. So now it looks very similar. Now, when I look at this one, I'm thinking, oh no, a complex trinomial, I have to factor it. Well, before I do that, I'm going to check for a common factor. And I'm going to try for a 3. Well, 3 goes into there, and 3 goes into 72, I believe, 24 times. So I'm going to take out the 3 first. So I'm left with k squared minus 11k plus 24 equals 0. Now it's a little bit easier to factor that. So two numbers equal 24. They add to give me 11. Both brackets are negative. All right, so multiplication facts of 24. 6 times 4. No, that only equals 10. 8 times 3. That would work. Okay, so then what we would do is we would set up our brackets. So we would have k minus 8 and k minus 3 equals 0. So now what we're doing, the 3 here, 3 equals 0 doesn't make sense. So I can't equal, that can't equal, 3 doesn't equal 0, so I don't have to look at that. Here, k minus 8, that would mean that k would equal positive 8, because I would add 8 to both sides. And then my other k value is going to be k minus 3 equals 0, so that would mean k equals positive 3. All right, and our final example like this, again, very similar to our last question, we don't have a 0 on one side, so in this case we're going to have to add 14 to both sides. And when we do that, we end up with 16n squared minus 140n plus 14 equals 0. Again, it looks like a complex trinomial. First, I'm going to try to factor something. 16, 114, and 14. Well, I know for sure a 2 goes in there, so let's try that. So that would be an 8n squared. This would be 57n, and 2 goes into 14 7 times. Okay, so it's still a complex trinomial. Okay, so it means I have to do some work here. And if I think about it, multiply to give me 8 would be a 1 and an 8, I believe. So I'm going to write that down, a 1 and an 8. and to give 14 would be a 7. Nope, in order to give me 7, sorry, would be a 1 and a 7. So which one do I want to go? I want to get a fairly large number. So I think I'm going to go 1 and a 7. Okay, so 1 times 1 is 1. 8 times 7 is 56. And I'm to add them to give a negative 57. Well, that will give it to me, so that's right. So I know my two brackets. I'm going to have a 1 and an 8 in the first position. I don't know what that's doing there. I'm going to unlock that and get rid of it. So I still have my 2. So I'm going to have an 8n in the one bracket. And I'm going to have a 1n at the position of the second bracket. And then when I look at this, now the reason they're both negative is they have to add to give me negative 57, so that's why both brackets are negative. Okay, just make sure that 8n is going to be multiplied by the 7. Now what we need to do is we need to actually solve this question. So remember 2 equals 0, can't have that. So 8n minus 8. Well, if you need to write that down a little bit further, you can. You could go 8n minus 1 equals 0. And this one is n minus 7 equals 0. So sometimes you have to write it down just to make it a little easier for your brain. When I do that, I end up with 8n equals positive 1. Divide both sides by 8, I end up with 1/8. And on this side, I would have n equals 7. So my two answers are 1/8 and 7. All right, so let's take a look at the next question. Okay, when I look at this next question, it looks different than the other ones. Now, why does it look different? Well, all of these ones had 3 terms. I maybe had to take it to the other side, but it still has 3 terms. So it means I'm going to have to do something a little bit different. So what I'm going to do is I'm going to pause the video and we're going to take a little closer look at this because my videos cannot be very, very long.